So class, good day. We are already on our module 4. So last time we talked about rectilinear kinematics on continuous motion and erratic motion. So in rectilinear kinematics, we discussed about particles moving along a straight line. So now we will be discussing about the motion of a projectile. So lesson preview. Uh, our topic is on motion of a projectile. And then, let me define the term projectile first. According to the dictionary, a projectile is an object propelled through the air, especially one thrown as a weapon. Any object thrown in the air is a projectile. So it's either balls, bagangilaba, shuttlecocks, missiles, and other projectile motions. So projectile motion consists of two axes of motion. When an object is thrown in the air, no matter the direction, it will always experience both horizontal and vertical motion, except of course when the ball is thrown straight upward. That only has a vertical motion. So, let's uh, define more. So in rectilinear kinematics, we talk about particles moving along a straight line. Now, we are talking about projectiles. So, a projectile is anything that is thrown upward. So, for instance, you have this object and you throw it that way, so it will experience motion like this. So, it is thrown. So, its motion follows this path. Okay? So, it was said that a projectile has two axes of motion. So, di ba? If sumura siya na siya duha ka components, if this is the direction of the object, therefore it has two components, the vertical and the horizontal. So the object rises and then moves to the right, something like that, until at such point that the object moves downward, therefore its vertical component is downward, but still the horizontal component is always on that side. So always for a projectile, the object experiences these two motions or components. Okay. So the free flight motion of a projectile is often studied in rectangular components. So motong components nun ay vertical and horizontal. The best example to illustrate the path of a projectile is this one. So in this picture, sequence nga gipakita. So as discussed earlier, ang projectile is all things thrown upward. It's either vertically, straight to the upwards, or katong naka-incline, which experience motion like this until it stops or halts. So ingani, may duha ka object, a ball, which was thrown. So from this point, this is a free fall. So na-fall lang gini siya ang ball downwards. And then this one, it was thrown to the side. So of course, iyang motion is towards the side. So kaning vertical motion, this is the free falling body. We call this the free falling body. Experiences only one component of motion, which is the vertical axis or the vertical component. While this one experiences two components of motion, the vertical and the horizontal. So inyo makita kani kay isa raman ka component, the vertical one. So inyo makita nga from here na ay change of elevation. So nagka change ang elevation but without changing on its horizontal component. So wala siya nisbog sa right or sa left, just purely downward. This ball, experiences change in motion or change in distance from the vertical component or from the y component. So yun yung makita at time interval t is nagka-dako ang distance, and also sa horizontal component niya nagka-change. So if you notice ang y is increasing but the horizontal component is constant. So later on ato maning ma-discuss. So if you notice no, ang duha ka object thrown, isa downward and isa to the side, fell at the same time. So this is for a free falling body without the effects of air resistance or other nga forces. Just plain lang siya nga, let's say na fall siya on this side. So ang duha ka object, maski pinaside siya or downward ang fall, they fall at the same rate or at the same time. So muna niyo makita na they are in the same elevation at each time interval. So also shown on this graph, you can see the x and y graph. So the x marks the distance, this one, and then the y shows us the elevation of an object. So this is the starting position of the particle. It was thrown that way from with a certain, of course, na siya certain angle from the horizontal, theta, we call that theta. So this object that is moving on that side has two components. We call that the x and the y component. So shown here is na velocity, right? The initial velocity or v naught. So the initial velocity, let's say v naught, na siya duha ka component, this one, the v naught, the initial velocity at x, and then the initial velocity na y component. Until such point, iabot siya ani nga point. So yung vertical component, so yung velocity final. So yung vertical component for the velocity Vy is downward na instead of upward like this one. But the horizontal component, the Vx, still moves that side, of course. So if you notice na atay acceleration. So acceleration from this point to this point is always constant. So this is the acceleration due to gravity. That's why A is equal to G. Acceleration due to gravity equal to 9.81 meters per second squared and always downward. Okay? So, naana po ta dire. So, there will be two set of formulas. So, di ba, ang acceleration niya is acceleration due to gravity. And that the acceleration due to gravity is always constant. It doesn't change through time. Ang gravitational acceleration will still be 9.81 meters per second squared. So, the acceleration due to gravity is always 9.81 meters per second squared or downward. Therefore, we can apply the constant acceleration equations from our previous topics on this topic sa projectile. Okay? So, since naa naman tayo duha ka components sa motion, diba, if we throw that object, na siya, let's say this is the velocity. So, na siya y component of the velocity, na po x component of the velocity. So, natoy katong top 3 na to nga equation, di ba? Constant acceleration. So, mo to siyang kishow diri. So, let's start with this one. The final velocity is equal to the initial velocity plus or minus the acceleration times time. And then the second one, we have the s, right? The final position is equal to the initial velocity times time plus or minus 1/2 a t squared. And then lastly, we have the final velocity squared is equal to initial velocity squared plus or minus 2 times the acceleration times the displacement s minus so. Now, sa projectile motion, let's say this is the object. Nato siyang gilabay. So if this is the direction of the velocity, siya x component and y component, right? So pag abot ani nga point diri, so let's say from this one to this one, itong gamiton na nga representation, instead of s we use x, or at other time we use r. We call that range. And then sa y, let's say mo travel mo na siya paana. So we can say this is y. or we say this the height h, and something like that. Since the motion experiences two components, so atong CV has two components na x ug cy. So the first equation, so this is the horizontal. We shall say this is horizontal. We can come up with this equation. So final horizontal component of velocity is equal to Vox plus or minus the acceleration times time. Remember that our acceleration for motion of a projectile, we consider only the gravity, the constant acceleration. So since it is a downward acceleration, it is negative. So Vox minus gt. So we can write it this way. But since this is the horizontal component and there is no horizontal component of the acceleration, therefore this is a 0. Since it is 0, then we get that the x component of the final velocity is equal to the x component of the initial velocity. So from start to end, the horizontal component of the velocity is just the same. So from the second equation, instead of using s, we use r or x. So we have that the s or the x is just equal to the velocity, initial velocity with respect to x times time. Since the acceleration along the horizontal is 0, then we just have this formula. And then for the third one, the v squared x, so we just substitute it with the horizontal component. The square of the vx is equal to vox squared, since our acceleration uh, is just 0, since this is along horizontal. So we have this equation. Then we extract the square root on both sides. We have Vx is just equal to Vox. So this equation is just the same with this equation. The final velocity along a horizontal component is just equal to the initial velocity of the horizontal component.